Okay, so to get your spreadsheet set up, I would suggest setting it up just like this. It would make things go a lot easier. So I just have these different parts of the experiment laid out. So this is the mass that you would have entered in, or that you measured out for your sodium carbonate. So I have trial 1, 2, 3, and then you have your burette initial, final, initial, final, initial, final, and then the temperature of your baths, and also the burette readings for this one. So that will help you to set this up. So the first calculation that you can do is to set up the to calculate for moles of sodium carbonate. And again, all the colored boxes is just where you're going to need to input data, and the rest of it we can do with calculations. Okay, so determining moles of dicarbonate, you're just going to set to this. You have to take the mass and divide it by the molecular weight of sodium carbonate. So I'm going to do equals. Just type in equals, select the cell, and you'll see that it highlights B2. And then I'm going to go here and divide by 105.99. And then that is your moles of sodium carbonate. And you can do one of two things. You can copy and paste this. So you can do copy and then paste it. So Control V, or just paste. And you can see here, if you're ever unsure, just highlight the cell here, this cell, to see what is getting divided. So it's C2, and that's correct. The other thing you can do is just drag this over, and it will copy the same formula over here. And then the next thing you can do is have it calculate your volume. So again, just push the equals button. You're going to select this minus the value above it and hit enter, and that will calculate your volume. And again, you can copy and paste each of the cells or just drag it across, and it will calculate it for you. To determine moles of HCl, there's a 1 to 2 ratio, so it is 2 times the moles of sodium carbonate. So again, I'm going to hit equals. I'm going to hit this cell because that's the moles of carbonate that corresponds to that, and then times 2. Hit enter, and then again you can just drag it across here. And then for the moles of the molar concentration of HCl, it's going to be moles divided by liters. So there's a couple of things, or one thing that you want to do here. So the molar concentration is moles, and you're going to divide it by the volume. And notice that this volume is in mils, we want it in liters. So you can do one thing here. You can do equals, it's going to be B7, and I want to divide by the mils, so it's going to be this value here, which is also divided by 1,000. So as long as you use the parentheses, that should be okay. So you have B7, which is the moles of HCl divided by the volume that's in liters. And you hit, there's an error, so sometimes that happens, and that is because I have too many parentheses. So I'm just going to erase one of those and then hit enter. So my value is 0.222339, which is correct. And then you could just drag those across. For the average, there was 3 cells here, and if you want to merge cells, you just highlight the 3 cells, hit merge and enter, or in center, and then you want to go to the formulas to find the average. And over here in AutoSum, there's an average. You can just click on the average. And then this is not the numbers I want to average. I want to choose these here for the concentration of HCl. So I'm just going to hit enter and then get the average for that. So again, if you're not sure if it did the right thing, you just click on the cell and then click up here, and it tells you what numbers are going to be average. So that's right. Okay, so for the temperatures, these are the temperatures in Celsius. And then for the volumes, again, I'm just going to do this minus the number above. And then get those values there. For temperature, now we need it in Kelvin, so you can set it up. You can do it by hand or set it up. So I'm just going to set it up. This is just this value plus 273.15. And then again, just drag it across to copy the cells. And then to get the temperature, to divide 1 over K. So this is K to the negative 1. So I have equals 1, and then you want to push divided by this value here, hit enter, and then drag it across. And then to determine moles used, we're going to multiply the volume used times the concentration that we found, the average concentration. So this is going to be moles used equals, I'm going to do parentheses here. This is the volume that was used divided by 1,000. So again, if you look where I'm typing in the box up here, this is where I'm getting that. So it's B17 divided by 1,000, and then I'm going to multiply it times the average. Okay, so notice that it is B9. For all of these other problems here, I want to multiply those also times this cell. I'll show you what happens here. If I try to copy and paste it, I'm going to get these weird numbers. And that's because it just takes it for the next values over. So it's going to multiply times B9, B10, or all these values over here where there's nothing there. So I'm going to go back to this cell here. If you put dollar signs here in the front of the B and the 9, it will divide only by this cell right here. I'm just going to put that yellow. So it's going to divide by that one. So again, now I'm going to recopy these across, and that has changed the values here. So I have this number of moles of HCl used, and those look reasonable to me. So for moles of borax that is used, there's a 1:2 ratio. So this is just going to be the moles of HCl used divided by 2. And then again, you can just copy those across here. And then the moles of borax, or the concentration of borax, is going to be the moles of borax divided by the 0.005. So again, equals this divided by the moles of borax divided by the 0.005. And that was the 5 mils that you titrated. So again, just copy and drag those across. The molar solubility is equal to the concentration. So you can just set that equal to this. You get that here. And then for, oops, I forgot one. For the KSP, you just take it's 4 times this cubed. So what you want to do is equals 4 times, and then parentheses, this, and then you want to use the caret 3. And then that will get you 0.0157. Again, you can copy those all the way across. So again, it was 4 times the B25, or the molar solubility cubed. And if you're not sure how to get these, where I got these from, go back to the other video on YouTube for the calculations, so that you can see how I got those. Okay, for natural log, now you can use this auto sum again. Go over here in this area to find the formula for natural log. So just click on more functions, and then enter in ln, and then it will come up with ln here, and then click OK. So it will ask you what you want to take the natural log of, and just select this cell, and then click OK. And then again, you can just drag these across here. Okay, so those are all of your calculations, almost all of them. Now you need to make a graph, so you can go to Insert, Graph, you can do a scatter plot. And this is your thing here. You want to make sure that you add axis titles and a chart title. So I'm going to go ahead and do this and pause the video here. So now I have this graph, and this is not the data. I don't think that is selected that I want to graph. So you can just click on here, one of the dots, and then choose Select Data. And then go to the series 1 and just edit it. So here is the series name. I don't have to worry about filling that out. For x values, I want 1 over t. So click on this select range, and you're going to choose 1 over t, which are these values. And then go ahead and click on this box again. And then you're going to choose the y values, which is going to be the KSP. So that is correct. Hit that and then hit OK. And it should give you a nice curve here. You can change the axis so that you don't have as many decimals if you want, or you can just leave it if you don't want to mess with that. That's fine. I'm going to switch my data on me again. So I'm just going to go back and select my data again. Okay, so what you can do is you want to do your trend line. So add trend line. And over here it will give you display equation on chart. So that's this value right here. You don't have to worry about the r squared. But once you have the slope, you can access your negative delta h over r, and then s over r, the y-intercept. So my slope, I'm going to enter it in here. That's negative 4507.2. The y-intercept is 11.63. Okay, so here I have the equation. This is where we get delta h. We're solving for h, and then we're solving for s, and then delta g at room temperature. So to get this for delta h, this equals your slope over here. So I'm just going to select this cell, and then it's just multiplied times r, which is the constant value over here. So that's your value for delta h. For delta s, it's equal to the y-intercept times r. So that is your r. And for delta g, it's just equal to delta h minus T at room temperature times delta S. So this will be equals this minus, and then in parentheses, 298K times S. So this is your delta G. So that's how you can set up the spreadsheet for that. If you have any questions, feel free to send me an email. Again, just look at the spreadsheet, kind of pause it on that first screen so you can fill in your boxes, and that will make things go a lot more smoothly for you.